Hello, welcome to your Unit 9 Day 6 notes on solving log equations. The point of today's lesson is to talk through two different ways that we will solve logs. So case 1 is when you have a log on one side. So a log on one side of the equation. What we will do is simplify any logs using our log properties, and we will lasso the log to turn it into an exponential form. So the idea is you simplify one side of the equation so it's a single log equal to a numerical value, and then I can rewrite it as 5 squared equals x plus 1, and from there we can easily tell that x would equal 24. Now, something that I'll emphasize with case 2 as well is to always make sure you check. So what we mean by that is when you have log base b of x, remember that the base cannot be negative. It also can't be 0. And the argument can't be negative. So I'm going to write a couple notes here. So our argument must be greater than 0, and b must be greater than 0 as well. Okay, so again, argument can't be 0 or negative, same thing with the base. All right, so moving on to our first example that we're seeing here, guys. So I already have a single log on the left-hand side equal to a numerical value of 6. Now this is your common log, which means it has an invisible little base of 10 that you're not seeing. So when I lasso to get out of it, this is 10 to the 6th equals x plus 4, which means there's 6 zeros there. Which means if I subtract 4, x will equal 9999996. So kind of obnoxious, but that's how we would solve it. All right, moving on to our next example. Okay, so here you're seeing 2 logs. So you can't do any lassoing yet. You have to combine that to one log. So I'm noticing that I'm adding the logs, and they're both natural logs, so they have the same base. So that means I can combine them to one log by doing our arguments of x times 4, or I'll actually write it as 4x because I like to do my stuff in standard form. Now remember that the natural log has a little hidden base of e that you're not seeing, so that's one of our other special logs. So I'll lasso, so I get e squared equals 4x, and then easily to solve for x you would just know to divide by 4. So x would equal e squared over 4, whatever that may be. Now, if we give you rounding directions, then you'd actually go to your calculator and hit the e button, which is at second divide. But for right now, we'll leave it with our exact form. All right, left-hand side here in number 3, I still have 2 logs, so I'm going to have to combine them. Now remember, anytime you have a coefficient on a log, we'll move that to the exponent location to condense it. So that's log of x squared. And subtraction relates to division. So I can rewrite this as a single log of x squared divided by 4. Okay. So then from there, guys, again, this is a common log, which means it has a hidden little base of 10. So when I lasso to rewrite it, I get 10 squared equals x squared over 4. Now from there, guys, I have 100 equals x squared over 4, so put the 100 over 1, cross multiply, and we get x equals technically plus or minus 20, right? Because if we're taking the square root of something squared, that means we're getting 2 solutions, a positive and a negative. Now this is where I told you guys, make sure you're checking here. That x is in the argument location of the log, and you cannot have a negative argument. So therefore, we'll reject the negative and only say x is equal to positive 20 as our final answer. Okay. Next guy here, again, combine these logs into one. Because I'm adding the logs and they're both common logs, I can multiply the arguments to create one super log. Okay, so this is x plus 2 times x plus 5 equals 1. Okay, now again, this is a common log, so we have a hidden little base of 1. So this is 10 to the first is equal to x plus 2 times x plus 5. Now make sure we completely distribute out that right-hand side. That's my computer warning me that my battery is going to die, so I'm going to have to plug in real quick. Once I'm done with the log equation, computer. Okay, so I have x squared plus 2x plus 5x plus 10. Now, it's a quadratic, so I'm going to have to set it equal to 0 to solve, but what I'm noticing is actually the 10s are going to drop out. So this will leave me with 0 equals x squared plus 7x. Okay, so GCF it. I can pull an x out of each. And tee it up. So I'm getting two solutions, x equals 0 and x equals -7. Now again, go back and check. Your x is in the argument location. So remember that all of that, ugh, that looks gross because it just turned black. All of that can't be negative. All right, so 0, if you plug 0 in, this would go to 2 and this would go to 5. So those are positive, so that's fine. So 0 will work. Now, as far as -7 goes, though, as soon as you plug -7 into even the first guy, you're going to get a negative argument overall, so we'll reject. So x equals 0 is our final answer. All right, good news. I plugged in my laptop, so we're good to go. All right, on to the next and last example of case 1. I have natural logs. I'm going to have to do some combining. That 2, I'm going to move to the exponent location, and keep in mind that subtraction is related to division. So I can rewrite this as natural log of x plus 2 squared divided by -x equals 0. Now, as previously mentioned, the natural log has a hidden little base of e. So when I lasso to rewrite this as an exponential, I end up with e to the 0 equals, I'm going to go ahead and FOIL this, x squared plus 4x plus 4 all over -x. Now, fret not, anything to the 0 power is equal to 1. So in order to solve this, guys, with cross multiplication, I'm ending up with -x is equal to x squared plus 4x plus 4. Okay, so when I add over the x to set it equal to 0, I'm now going to look to factor. And I'm getting two potential solutions, x equals -4 and x equals -1. Now remember, you've got to go back and check here. So if I plug -4 in for x plus 2, that whole argument is going to go negative. So therefore, I cannot have x equals -4 as a solution. Now what about x equals -1? -1 plus 2 is positive, so that's good. And then if I look at the other argument, -1 is positive as well. And that's how x equals -1 is your answer. Okay, so that's all of our case 1 solving for logs. Now to make sure you haven't completely tuned out here, what I want you guys to do on your homework when you submit it to Google Classroom is draw a star next to your name. Thanks. All right, moving on to case 2. Now, case 2 looks like examples 1 through 5 on the right-hand side where you're seeing multiple logs. There's logs on both sides of the equal sign. So for case 2, we'll write logs on both sides. So we will continue to use our properties to get it to be 1 log equals 1 log. And once I have that, we can drop both logs and solve. So for example, if you have log of 5x equals log of 15, drop the logs, you end up with 5x equals 15, and so x equals 3. This is very much like when we were solving exponential equations and we would get something that looks like this. 2 to the x equals 2 to the 12th. I'm just making that up, okay? If the bases are the same, you drop the base and then set the exponents equal to each other. It's the same exact idea because logs are inverses of exponentials. All right, so coming on down to number 1. Remember, you want a 1 log equal to 1 log. So I see 2 logs on the right-hand side. Well, lucky for us, we know our log properties. So this is log of 4x by using multiplication. Log equals log, so 28 equals 4x, so x equals 7. Okay, same idea for 2. I see multiple logs on the left-hand side, so I'm going to use my properties. Move that 3 to the exponent location and no additions related to multiplication. Now each of these are log base 7, so those drop out. So I am ending up with 2x cubed equals 16, which means if I divide by 2, x cubed equals 8, so x must equal 2. Okay? Nothing I've had to reject so far. All my arguments would end up being positive. All right, a little bit of multiplication here, guys. So this is log of 2x plus 3 times x plus 4 equals log of 2x squared plus 11. Okay, so log equals log. They're both common logs. They have the same base, so I can drop them. I'm going to FOIL the left-hand side here. So this is 2x squared plus 8x plus 3x plus 12. So this problem looks like it's going to be nasty, but check out those 2x squares. They're going to drop out. So we end up with 11x plus 12 equals 11. So 11x equals negative 1, so x must equal negative 1/11. Now that negative 1/11 might concern you guys, but if you plug it back into the argument here, that'll still be positive. Same thing here, still positive. Here, well, definitely still positive because it's going to be squared and go positive. So you're still good. You don't have to reject anything. So your final answer is x equals negative 1/11. So I'm just saying that because I don't want you guys to be like, oh my god, I got a negative answer. I got to reject it. No, it's only if they cause the argument or the base. We haven't gotten to that yet, but the argument to go negative. All right. Right-hand side here, I have multiple logs. Let's combine those. Okay, natural log equals natural log, so those drop. Now I'm going to get rid of that fraction by putting the x plus 2 over 1 and cross multiplying. So we end up with 12 equals x plus 2 times x plus 3, and then we'll just FOIL that out. Okay, so 0 equals x squared plus 5x minus 6. So factors of negative 6 that sum to positive 5, so that would be 6 and negative 1. So we're ending up with two solutions here. X equals negative 6 and x equals positive 1. Now let's go back and check here, guys. The negative 6, when I plug it in there, right away going negative. So that's out. So let's look at x equals 1. This would be positive. This would be positive. So there you have it. X equals 1 is your final answer. All right, last one, and then we'll mix it all up. So for number 5, okay, you have to make sure you are condensing your logs first before you start dropping stuff. So I have to move those coefficients to the exponent location first. Okay. Log base 3 equals log base 3, so drop those. So I'm ending up with x to the 1/2 equals 4, because 2 squared is 4. Now I can raise both sides to the second power to undo that 1/2, or square root if you want to think about it that way. And you'd end up with x is equal to 16 as your final answer. And there you have it, guys. So those are your two different cases of solving logs. So you just got to identify, do you have logs on one side of the equation or on both sides? Logs on one side means you'll be able to lasso to write it as an exponential. Oops. Logs on both sides will mean that you'll be able to drop the logs and then just solve the arguments by setting them equal. All right. So coming on to the next page. So you got examples 1 and 2 here. So starting with example 1, guys, I'm noticing that I have logs on one side of the equation. So this would be like the left-hand side of the table that we came up with. So what I'm going to do is move that 1/2 to the exponent location. And then lasso to rewrite it as an exponential equation. Now, in order to solve for x here, guys, I'm going to have to undo the 1/2 power. So what I can do is square both sides. And that'll leave me with x plus 2 equals e to the 4th. So in order to solve for x, I would just subtract the 2. And we'll just leave it just like so. That's your exact answer. Again, if we wanted a rounded answer, we'll ask you for it. All right, now moving on to log equation 2. Log, 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 log. So this is your case 2. We have logs on both sides of the equation. So let's go ahead and combine both the left and the right separately. So subtraction relates to division. So that means this is log base 3 of 20 divided by x. Addition relates to multiplication. So this is log base 3 of 5 times x. Log equals log. So we have 20 over x equals 5x over 1. So I'll go ahead and cross multiply. Divide by 5. And this is another one of those scenarios, guys, where technically you're getting 2 solutions, plus or minus 2. However, because your argument here is x, you can't have negative 2 as a solution, so x will equal positive 2. All right, moving on to 3. I have logs on one side of the equation. And this is actually pretty nice because all I have to do is just lasso. Done. So this is x to the negative 2 equals 9. Now, in order to undo the negative 2, you're going to have to raise both sides to the negative 1/2. So just like what we did in our exponentials unit. So this is then x equals 1 over the square root of 9, which is technically 1 over, or plus or minus 1/3, I should say. Now, the argument, or the base, just like the argument, can't be negative. Okay, so just trying to be clear there, guys. Yes, technically, algebraically speaking, you're getting 2 solutions, but in a log, the base can't be negative. So you'll reject the negative and accept only the positive solution of 1/3. All right, now this one, I'm going to keep with this color coding I've seemed to start to do. I have logs on one side of the equation again. So unlike 3, I'm going to have to do some combining. Okay, any coefficient moves to the exponent location. Multiplication relates to addition. So this is the natural log of x squared times 5x equals 1. And then remember, there's a little hidden base of e in a natural log. So we end up with e to the 1st is equal to 5x cubed. So in order to solve for x, we'll first divide by 5. So we get x cubed equals e over 5. And in order to solve, we'll just use the cube root, or raise to the 1/3 power. They're the same. So here's our final exact answer. All right, now number 5 is a bit unique because I'm seeing logs on both sides, but the issue is it's not log equals log, and there's no way I can combine 2 minus log x. Okay, now if it was log of 2 minus log of x, then it would be a different story, but that's not what we have here. So I'm actually going to do a little bit of manipulating. Let's add the log of x over to the other side. So this is log of x plus log of x equals 2. Now this is looking a lot like our case 1, or the left side of our table where we have log equals log. So I'm going to select my little pink color again. Did I say log equals log? I meant a single log equal to a number, or how I can get logs on one side of the equation. All right, so on the left-hand side, this is x times x, so x squared. So log of x squared equals 2, and the base of a common log is 10. So this is 10 squared equals x squared, or 100 equals x squared, and we take the square root. So technically 2 solutions, plus or minus 10, but argument's x, we can't have a negative, so therefore x must equal simply positive 10. All right, we just got 2 more to do, and they're both the same type. I'm seeing logs on both sides of the equation in number 6, and same thing in number 7. All right, so that means I'm going to grab my navy blue pen, since apparently I'm color coding now. All right, so addition relates to multiplication. So log of 2x times 2 equals log of 16. Log equals log, so I have 4x equals 16, so x equals 4. That one was easy. And last one, subtraction relates to division. So this is the natural log of 4x plus 16 over 2 equals the natural log of 3x plus 5. Natural log equals natural log. Okay, now if I cross multiply here, this ends up with 4x plus 16 equals 6x plus 10. I just distributed the 2 there. So subtract 4x, that'll give me 2x. Subtract 10, that'll give me 6. So x equals 3. And you're done. All right, guys, thanks for watching. This is how you solve both cases of logs. Make sure you do your homework. Bye.